Okay, hi, and welcome back to the classroom. Just wanted to show you some of the things we've been working on over the last couple of days. We've been talking about transforming energy, and it's a big part of Lab 3.1. And the way we've been doing this is by taking a look at three specific ways that we transform energy, not once, not twice, but maybe even three times on the way to becoming something. Okay, let me give you an idea. Okay, let's take a look at the first of our three stations. That happens to be this sort of this wood ukulele. We called it bouncing sounds, and really that's what it is. Sometimes, when you go into your first or second music class, you get a teacher who gives you a Kleenex box and a whole bunch of elastic bands, and you sit there and you plunk them, right? And I know that sounds really simple, but this is really a complicated piece of machinery. Complicated not because of the way it's built or the way you operate it, but complicated because of the amount of transformations of energy that we actually do to get this to make sounds. Let me give you an example. I ate breakfast this morning, right? I took in that chemical energy from the food I ate. I am able to transform that chemical energy into kinetic energy. I'm able to take that energy and make it into something that I can move with. Well, I use that movement to plunk the strings on the little wooden ukulele here, right? So what I'm really doing is I'm transforming energy that I ate this morning. And by the way, if you want to take a step back, I'm actually transforming sun's energy because, of course, that's where the food got its energy, right? I'm taking that energy and I'm transforming it into something I can use. So we're taking food energy, we're making it into kinetic energy, we're making sound energy out of it. And in fact, if I kept plunking on this thing, I could probably provide you with some heat energy as well, too. So a whole bunch of transformations in a very short period of time. Another example of that is this little thing. Okay, I showed this to you in class. Okay, they're the hot hands hand warmers. Okay, now the neat thing about the hand warmers is these are all natural ingredients. It's just iron powder and a little bit of water and some salt and various other things. When it's in the packet, which is airtight, when it's in the packet, no air touches it and there's no chemical reaction. But as soon as I take it out of the packet and move it around a little bit, there's a chemical reaction that creates heat. In fact, it creates a lot of heat. I can get about 52, 53 degrees Celsius out of this thing. And you can slip it into your gloves or you can slip it into your boots, whatever keeps you warm. But what's fascinating about this here is the actual way that you get temperatures to work. I am taking chemical energy that's held in in the ingredients here, and with adding a little bit of air and maybe a little bit of movement, I'm creating heat out of it. Think of all the transformations that are going on here. Okay? And if this isn't complicated enough, and if the ukulele wasn't complicated enough, think about this thing. Okay, actually, let me move it back because you can all see it there. The lamp is a good example of a very complicated chain of transformations. We can't just think about me flipping on the light and the light going on. Okay, there's more to it than that. You have to go back to where the electricity actually came from. Think of it. All of our major energy starts with the sun. So whether it's the sun's energy that's trapped in coal or natural gas or any of those things, or whether it's the sun's energy that helps to provide the whole system of the water cycle so that we can use hydroelectricity. The sun's energy is actually what comes out of here. Let me give you an example. Okay, think hydroelectricity here for a second. The sun's energy keeps the water liquid. Okay, the Earth's gravitational pull keeps the water moving. It goes past a turbine, makes a generator go, sends the electricity down the wires into this, and by flipping the switch, the light bulb transfers that electricity into light, but also into heat too. Okay. On top of that, if this were a fluorescent light and not in such great condition either, it would probably make a low humming noise. So it also could make potentially sound energy too. So go through that. You get sun's energy going to electrical energy as a result of kinetic energy, then becoming electrical energy, then going into here and making light energy, heat energy, and potentially sound energy too. So these are three very complicated systems. We don't think of them that way. We're just turning on a light. Okay? But they are very complicated systems of energy transformations that provide us with what we need every single day. All right? And this is also the basis of Lab 3.1. So get back to work. It's due on Monday.